Following on from the previous two videos, we got to this stage here. Where hopefully by now you can accept this first step. You can accept this. So just a summary of what we've done. When given these parametric equations, time is the driver of everything. So when given a time, we can plug it into this t here. That will then give us the x coordinate. So that will then give us the x coordinate. When time is a driver of everything, so when given a time, we can work out the y coordinate by plugging it into here, and then this here will then give us the y coordinate. That will then give us a y coordinate. So looking at this, time is a driver of everything. When given a time, we can work out the x coordinate. We can work out the y coordinate. So this thing here can be written as y. So y is in effect this thing here. And this thing here, it can be written as x. So we can imagine this as being x, or we can imagine this as being y. So in the previous two videos, we got to this stage here. So looking at this, well, don't forget this thing here can be written as y, and this thing here can be written as x. So looking at this, we can put this. Remember, this is also y. So we can put this into here. So that will then give us so y can be written as this, and then don't forget we've got this can be written as x. So we can put this into here. So we've got f of t. So from here, that will then take us to here. So here you've got an equation. With an equation, you can add equally, take away equally, divide equally, or you can differentiate equally as well. So differentiate this side and this side. That will then give you this. And the reason why it gives you this is because you can imagine this as being a bubble here. So when you differentiate this, you've got to use the chain rule. So the chain rule will take you to here, because you would differentiate capital F as normal, and then you've got to times with the derivative of the bubble itself, of this thing here. So let me just illustrate this this step here. So in order for you to differentiate this, you would have to use a chain rule. So you differentiate capital F as normal, and then you've got to times the derivative of the bubble itself here. So let me just illustrate this next step here by using our previous example. So the example in our previous two videos, we were given this as an example. So to jump from x to here, we would have to jump back to here. So that would be this, and then from here, we normally have to do t squared times 3. We would have to do this squared and then times 3. The point here is that if you're trying to differentiate, the point here is that currently this thing here is very similar to this thing here. So when you differentiate this, you have to use a chain rule to take you to here. So when you come to differentiate this here, you would have to use a chain rule. You have to differentiate it. So it will give you 6 bubble, and then you've got to times with the derivative of the bubble itself. So you would have to do. So it's really you using the chain rule here. So if you differentiate this, differentiate capital F as normal, and then you've got to times with the derivative of the bubble itself. So when you differentiate this, when you differentiate both sides, it will then take you to here. So now looking at this here, now looking at this here, don't forget we can replace this with x, because looking at the diagram here, looking at this here, don't forget this thing here can be written as x. So I'm just replacing f of t with x. So hang on. So we were here, differentiate both sides. That will then give you this. But then now replace this with x, because x is f of t. So replace this with x. That will then give you this. So now you've got this thing equals this thing times this thing. Divide both sides by f prime of t. So that will then give you this. So when you look at this here, remember right from the start we said y equals capital F of x. So if you differentiate this with respect to x, you will have dy by dx, and then differentiate this with respect to x. That's the same as this. So when you look at this, this is really dy by dx. This is really dy by dx. So you can imagine this as being dy by dx. So now dy by dx, which is the derivative, is simply you differentiating g of t and you differentiating f of t. So what that means is dy by dx. What that means is dy by dx is equal to this thing here. So what that means is in the previous example we were using this. So what that means is looking at this. This is dy by dx. This is dy by dx. So if you want to find dy by dx, you simply differentiate g. You simply don't forget what this thing is in parallel with this. So if you want to, so you differentiating the g here, you finding out g prime is really you differentiating this. So in our case here, if you want to find dy by dx, simply follow this. Differentiate this. So that will be 6t divided by differentiate this, which will be 2. So dy by dx. So dy by dx is simply this thing here. So it's really us. So if you want to find the derivative, it's simply a matter of you differentiating this divided by you differentiating this. So it's simply you differentiating this divided by you differentiating this. So that's our derivative.